I am the Tofu Golem. Please enjoy the video.
You begin by loading Coil Inventor and opening a new project. You must set core geometry and conductor properties now. Enter core diameter, length, and select winding style so the program can calculate turns automatically. Once done, pick conductor gauge and insulation values. These directly affect resistance and spacing. Make sure to choose the target inductance or frequency range, so the tool prioritizes that parameter when it suggests turn counts and layer arrangements. You now configure winding specifics. Set turns per layer, pitch, and how many layers you need for the physical coil. Adjust packing density and interlayer insulation to control stray capacitance. This matters for high-frequency coils. Once set, enable taps or multiple taps if you need adjustable coupling or matching. Run the simulation and inspect inductance, DC resistance, and estimated self-capacitance. The software gives visual layer-by-layer views, so you can iterate quickly and reduce iteration time. You finish by validating physical dimensions against the enclosure and exporting manufacturing files like Gerber, BOM, or PDF layout. Export connector and tap coordinates too. Once printed or wound, follow prototype notes for tension and soldering to preserve inductance. If measured resonance or inductance differs by more than 5%, first check winding spacing and tap placement in the model, then rerun the simulation. If problems persist, increase interlayer insulation or slightly reduce turns and reevaluate.
Thanks for watching. Consider subscribing if we helped you today.